to show you all a thinking process. We talked about thinking skills. Y'all remember analyze and perspective was a thinking skill that we used to look at our photographs, and based on different perspectives would determine the kind of math that we saw. Y'all remember doing that? Alright, so the very last thing that you have to do is to create your original math story word problem. Okay? And I'm going to go over that with you and talk to you about a thinking process that you are going to use. Alright? And this thinking process is called decision making. You're going to be making some decisions based on the choices that you have in front of you. Okay, so I'm going to go through that thinking process, and this is the process that you're going to be using to create your final product. Alright, what is a thinking process? A thinking process is a process that requires multi-levels of thinking. Okay? And it requires a combination of thinking skills that progress towards a goal or a product. So we have done analyzing perspective. We've done evaluation in the past. We've done, error analysis and compare and contrasting. But we are going to be looking at the two thinking skills, analyzing perspective and evaluation. Okay, so decision making is a thinking process that evaluates alternatives to determine a course of action. Okay, so evaluate alternatives will be the choices that you get to make. Based on the choices, the solutions, you're going to determine which is the best approach to take. Okay? Alright, here is a flow chart, and I'm going to be giving you one of these, which looks a lot better and a lot easier to follow as to what you should do on your word problem. But this here is a summary. What you're going to do, you're going to use the thinking skill, analyzing perspectives, to determine three perspectives. So once you, remember all of this, we've been looking at photographs, okay, and we're doing this, we're looking at photographs and we're analyzing different perspectives in the context of math, okay. So you're going to think about three different ways or three different perspectives, and then you're going to determine which is the best perspective that will give you a better or more interesting story. Okay? And then once you think about the perspectives, you're going to decide which is the best, again, the best perspective that will provide the most interesting story. Then, after you do that, you're going to use the thinking skill evaluation to determine what math concept is applied in the picture or even implied, suggested, that could happen in the scenario that's provided in your photograph. Okay? And once you determine that, based on the perspective that you chose, you're going to create three math problems that will be most appropriate from that person's point of view. Okay? And then you're going to put your math problem and your story together, and then you're going to create your original math problem. Here is the picture. This is an example picture. So I'm going to go through the process. I'm going to kind of model the process of how you would approach your final project, because each of you all are going to get a different photograph. Okay? And so here, this is a photograph of a man on a high wire riding a bicycle, I guess getting ready to perform a stunt. Okay? So I'm thinking about what perspective, as I analyze this photograph in the context of math, what perspectives am I interested in? So first of all, let me go from the perspective of a spectator down on the ground looking up at this guy riding this bike. Okay, so if I'm the person looking at him, I'm probably wondering, oh my gosh, that is really, really high. He is very bold to even get up there to do this. He has to have, what, so much, he has to be able to balance well. And then he has to be able to, he has to have a lot of confidence. So I am, wondering how in the world is he feeling up there. So I would be in awe watching him. All right, so what if I came from the perspective of the guy who's actually actually on the bike? Well, if I was that person, I would probably be talking about, man, look at all these people down here watching me. I better hurry up and get across the line. I better, get my stick and make sure I balance myself. I wonder how fast I can go without messing up. It's really warm up here, and I better give a good show. Okay? All right, so there's another perspective, let's see, that we could think about. And because of the way the photograph was taken, what about the person who actually took the photograph? Okay, so because if you were down on the bottom taking the photograph, wouldn't the angle be upward? So obviously someone is like right on his level, either on a building, either in some type of apparatus where they're able to take a picture of him. So what if I was a photographer taking the picture of this guy and watching this guy go over to the other side? I might be thinking about, am I going to get a good shot? Is my view good? Is my camera in focus? Man, it's high up here. Or, he's very bold to be doing this. And I wouldn't want to be doing it. So if I was a photographer, I would have a different point of view. And based on the different perspectives will be the different kinds of math. Okay, so if I'm a spectator down here, I would be concerned about height, how fast is going to be going over, how long will this take. If I was the guy on the bike, how fast can I get over? How much weight do I need on my balance and beam to keep me balanced? How long is this rope? And then if I was a photographer, am I high enough? Or, how fast, how slow does he have to go in order for me to keep him in the frame of my photograph or my camera? So there's all kinds of math. What about the temperature? Man, it has gotten hot all of a sudden. It started cool that morning. It's gotten hot by the time he is actually doing the act. Okay, so there's all kinds of math. All right, so what I've done ahead of time, I have decided to go with the perspective of the man on the bike. Okay, so I wrote a really quick write-up on what he might be thinking. Okay, so this is my little quick creative story. As the man prepares himself for his stunt, he thinks to himself, here goes. Man, there's so many people down there watching me. I better do my best and make it across this line. Well, if I pedal fast, I'll probably get across quickly. But if I do that, I may fall, and that won't be good. So I think I'll take my time and pedal steadily and slowly. The weather's great, so I better give a great show. So that's just my little spiel from the perspective of the guy. Okay, so that's my introduction of my word problem, or my story problem. Now the next thing that you have to, once you decide the perspective, now I have to decide the math that is appropriate from this person's point of view. And what I decided to use or these are the things that I think would be appropriate for him. Which would be, and these are things that we've studied in 7th grade. The circumference of the wheel of the bike, how long is the high wire, the speed or the rate, how fast you should go, and the temperature outside. Okay, that's dealing with integers. When you're talking about temperature change, you can use integers there. All right, and so based on the concepts, I came up with 3 math problems. Okay, that's pertaining to the story. If the high wire is 100 feet long and my speed is 10 feet per minute, that's rates, how long would it take me to cross to the other side? All right? The next one, if the radius of one wheel is 11 inches, what is the circumference of the wheel? Would a bigger wheel get to the other side quicker? And then third, this morning the temperature was 65 degrees. 4 hours later, the temperature has risen to 79. What was the average temperature increase per hour? All right, so these are the types of questions where you put it all together. But do you see how this is from the perspective of the bicycle person? Or the man on the bike?
What perspective did you come from? On your, did you decide to write about?
How
Who are you in the math story?
the person that is selling the fruits and the vegetables.
Oh, okay. So you're gonna be the seller. Okay. What perspective did you decide to write from?
The guys on top of the water barrel.
Oh, so you're one. Let me see your picture. Oh, so you're the guy on the. Oh, one of the guys on the water tower.
Mhm.
Okay. Sure. Who did you decide to write? Who are you? What perspective are you writing from, or making your story from?
The park.
The what? Have you thought about it?
That's what I'm thinking about now.
Okay. What perspective? Do you understand what I mean by perspective? Are you, are you the person playing in the park? Are you, are you
the builders that built the park.
Okay, you're the builders that build the park. Good job. What are your questions?
How much area and volume does it take to build and fill this tank of water?
Okay, and what's your other question?
How tall are the buildings around the water tank?
All right, and?
How long have you been working on the water tank?
Okay, now, to finish this, you're going to have to answer your own questions, right? And do you have enough information? You have to decide whether or not you have enough information. Have you provided enough information in your problem to answer your questions? Can you find the area and volume? What do you need?
To measure the area and volume.
So you need some what?
Information.
Dimensions. Yeah, you need some information, some dimensions, right? So guess what? Since this is your story, you get to what?
Make up my own.
Make your own measurements. All right? And so what are you measuring? What's the shape of the tank? Yeah?
Cylinder.
A cylinder, right? And so you have to ask yourself, well, what measurements would I need to find the volume of a cylinder? Correct? Can you find the area of the cylinder? What kind of area do you find on the cylinder? Starts with an S. It's 2 words. Remember surface area? All right? And you know what surface area is, right? You find the areas of all the 2-dimensional figures that make up your 3-dimensional figures. So what 2-dimensional figures make up a cylinder?
A circle and
Circle and a
rectangle.
rectangle. So you need to have some dimensions of a circle. What you would need to find the area of a circle, and you would need whatever you find the area of a rectangle, right? So you get to make that stuff up, but make sure you answer your question. And so, all right, and I'll come back and help you. But good, those are good questions. Great job.